I'm Titus Winters. I'm the tech lead for the C++ library team at Google, which is responsible for many of the fundamental infrastructure utility sorts of APIs in Google's C++ codebase. This means I work very broadly throughout the codebase. I have kind of the 10,000-foot view of one of the largest codebases in the world. I make and review changes throughout that entire codebase. I do a lot of training and writing internally. The not really far off statement that I make is Google's C++ codebase is my product. One additional way that I affect C++ development at Google is that I'm one of the style arbiters, which is a group of 3 of us that are empowered to make decisions about what does and does not go into the style guide, and generally is setting the path forward for our C++ codebase in the next 5 and 10 years. This talk is partly about our style guide, but only as a mechanism to start the general discussion about style guides overall. I kind of want this to be a meta discussion on what do you get out of a style guide and how should you make those choices. This is really a style guides, how do they work sort of talk, okay? I thought about just retitling it Style Guides, but titles for this talk was submitted so long ago that didn't have the opportunity. So clearly, this is a talk about style guides. So clearly, this slide here is the most important, right? We're just talking about how do we format our code, right? 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 Anyone want to take the bait on that? This is a boring and stupid question, right? Specific, dear Lord, right? As far as I'm concerned, go use Clang format, right? How many of you have heard of Clang format? How many of you are using Clang format? Next year, I want every single hand in this room to go up, because if you are not, you are just sadly in the dark ages, right? Like, ooh, ow, painful. It is better on average than humans by a significant amount. I have looked at hundreds of thousands of lines of code formatted by humans and formatted by the robot. The robot is better than you on average. We do not yet require globally that Google C++ code is just blindly formatted, because there are some places where domain expertise and specific knowledge matter. Formatting a matrix, for instance, still has some human judgment to it. The robot can't quite identify, oh look, that's got structure to it. Failing that, I rarely see this go wrong. So go use Clang format. And this talk is not about that. So perhaps this talk is about what goes into a style guide. And I would say that this is still not quite a high enough level question, right? This is not about what does and does not go in. This is about why something would go in. Okay? What is the purpose of a style guide? Right? What is your organization getting out of having a set of rules? Right? What's the purpose of any set of rules that your organization puts out? Right? Clearly, we have all learned the important lesson from our middle school PE teachers that rules are there to throw your weight around and make people jump through stupid hoops. Right? Now you all need to get down and give me 20 push-ups. Right? This is not what rules are about. Right? You should not be setting rules in your organization willy-nilly. Right? Rules have cost. Okay? A style guide is here to make it harder for people to do bad things and easier for people to do good things. Since your style guide probably is silent on questions of kidnapping and murder, I am using these in air quotes because, let's face it, there's a matter of taste and judgment here, right? Figure out which things your organization cares about and try to encourage and discourage accordingly, okay? Generally, for this talk, I'm going to talk in 2 parts and then let you guys bring out the pitchforks and torches. First, I'm going to look at the underpinnings of Google C++ style guide. Okay? These are the things that we have identified as the goals that we are trying to serve with having rules. Right? We have identified 8 kind of base principle things that we aspire, like goals serve these purposes. Rules serve these purposes. Then we will talk about the contentious rules, which is, I'm sure, what got you all out of bed at 9 in the morning. And then we will have lots of time for Q&A. You can point out new contentious rules to me, and we can spar. It'll be fun. Okay? So in order to understand the rules that Google has set forth, you have to understand the context in which those rules are applied. Okay? I will be completely blunt. I don't care if you use Google's publicly available style guide. In fact, in many cases, it's probably optimizing for a different set of values than your organization needs, right? How many of you work for a company that's less than 2 years old? Wow, seriously? There are no startups in the audience? Huh. How many of you work for a company that has less than 10 million lines of code? Fewer than 10 million lines of code. 1 million lines of code. Also interesting. How many of you have fewer than 200 coworkers? How many of you know almost all of the other coders in your code base? Yeah, there we start to get big differences. All right. About us. There's 4K-ish C++ engineers. It's actually really hard to get a decent census on this. This is kind of my best guess. We work in a shared code base. It is a single monolithic code base with a very strong testing culture. It weighs in at 100 million-ish lines of code. One thing that is really critical for us, has become increasingly valuable in the last couple of years, is we have an indexer for our code base. Right? This is maybe not a term you're familiar with. A lot of the rules in the Google Style Guide from back in the day were based on the notion that if you wanted to figure out where something was being used, you may have to grep for it. It is not easy to grep for operator equals or uses of operator equals. Right? This is not a trivial thing. Right? We have an indexer. We started talking about this publicly about a month ago, I think. There was a talk at Twitter. The tool is called Kith, and what it does is it takes the parse tree out of Clang, because Clang is the hammer for all of our nails. It takes the parse tree out of Clang and indexes all of the nodes in the parse tree, right, across the whole code base. Right? So when we want to know now when is operator equals on this object, on this class being called, we know exactly everywhere in our code base that that exists. Grep is no longer an interesting part of our maintenance strategy. Another important piece to be aware of is that there is a wild variance in C++ background. We have a lot of engineers. We hire a lot of engineers. We hire a lot of talented, yes, new grads, but I don't see a lot of university programs that focus a lot on C++. I would love to be proven wrong on this. How many people graduated in the last couple of years and had more than a year worth of C++? How about Java? What did you guys study? Well, is it C++? Yeah, sure, but like, what did you study in school? If not, I'm curious. Okay, fine. Fortran, clearly it's Fortran. We have a wild variance in C++ backgrounds, right? So I would say that most new grads, if they got C++ background at all, probably have like maybe a year's worth of experience with it in one class, right? So that's, let's call it 100 man-hours of required C++ background. Many have more experience than that, but it varies. Then on the other end of the spectrum, we have ACM fellows and Lifetime Achievement Award winners and people on the standards committee and et cetera, et cetera, et cetera. Right? There's some range here. We want to make sure that everyone can operate, not just the experts. Thankfully, we have very, very good code review policies. Thankfully, this does mitigate some of the variance in C++ background because it's going to take some expert understanding before anything gets checked in. And one of the things that I think is most important, we expect we'll be around for a while. It is hard for me to envision scenarios where we are not largely working in this code base 10 years from now. I kind of don't see Google tanking completely in less than that amount of time. And I kind of don't see Go killing C++ off in less than that amount of time. at least not for our usage. If it happens, that'll be interesting, but I'd be surprised. Therefore, if we have a knowledge that we're going to be around for 10 years, we need to start planning to make sure that we're not dragging and increasing weight after 10 years. Most projects checked in the same code base. Drat.
Too slow.
I did, sorry. Most projects checked in the same code base. Most engineers have read access to everything in the code base. Most projects in the code base use the same basic infrastructure, build system, common libraries, all of that. Okay? That's us, right? In these contexts, the rules get applied. All right? Code is going to live a long time, be read many times. We are optimizing for the reader, not the writer, which is actually philosophy number 1. Optimize for the reader, not for the writer. We are far more concerned with the experience of code readers. This is not unusual, but this is explicit decision and philosophy number 1, right? The code is going to be written many, many, many more times than it is to be read many more times than it's written, right? You will spend much, much, much more time looking at it than writing it. We kind of don't care if it's tedious to type it, so long as it's clear for the reader. Rules should pull their weight. We're not going to list every dumb thing you shouldn't do. This is not a good use of rules, right? Specifically, we don't expect the style guide to be interpreted in a lawyerly fashion. Occasionally it happens, but we're not going to go through and list off absolutely every action that is illegal. We would rather have a high-level rule, don't be clever. A similarly valuable high-level rule would be, don't be stupid. We should add that. We would like to value the standard but not idolize it. Right? Not everything that goes into the standard is the solution for all problems. Tracking the standard, however, is valuable. Right? The more that we stick close to the standard, the more that publicly available information helps. Right? CPP reference is a great reference because everyone is already using the same things. Spending the same amount of time and effort on getting internal docs up to date would require more manpower than I have. So, value the standard. Moving now down into more and more concrete things, be consistent. Right? Consistency allows expert chunking. By chunking, I mean in a cog-sci sort of sense. If you look at how expert chess players work, they are not thinking about the positions of individual pieces. They are looking at configurations of pieces and how those are likely to play out over time. Right? There's a cognitive difference in how experts perceive a problem than how novices perceive a problem. Right? This works when things are structured in similar ways. Right? If we solve all of our problems with the same set of infrastructure and interfaces, and we format them in reasonably consistent ways, it's much easier for an expert to glance at a piece of code and understand what it's doing. This is much like what Bjarne was saying yesterday, with find if. Right? Consistency also allows tooling. When everyone is using the same mutex, we can decide at some point to add deadlock detection to how we handle our mutex, for instance. When everyone rolls their own mutex, no such ability. Right? This is obvious. And consistency, of course, also allows us to stop arguing about stuff that doesn't matter. All of the formatting stuff. Just not interesting. Things that fall into the be consistent category. The obvious stuff. Right? Include guard naming, formatting, parameter ordering. We say inputs first, then outputs, unless there's some reason to do otherwise. How do you name your namespaces? Declaration ordering. Where do things go within the structure of a class? Null pointer, naming of variables in general, camel case, underscores, all this stuff. Formatting. And don't use streams, because our code base consistently does not use streams. Except it kind of sort of did. And when we were going through actually prepping this, we decided, this actually fails all of the previous 3 tests, right? Like, it's not consistent. Like, we've already kind of violated our consistency principle. It's like format strings are a little tricky from time to time. It's not obvious, right? This just kind of, it didn't pull its weight, right? We weren't getting nearly as much value out of having this rule as we were taking pain for people wailing and gnashing of teeth over this rule. So there is a change out right now, which sometime will get checked in, that will strike this rule. So we're not zealots. One of my absolute favorite rules: if something unusual is happening, leave an explicit trace for the reader. So the old example of this stems from no non-const references. Right? If you do not pass, if you only passed const ref through interfaces, that is, if as a function argument you do not take non-const references, then when you have a value and you want to pass it to a function that might mutate it, by necessity, you have to add the ampersands. This leaves a trace to the reader. Reading this and knowing that rule, you guys can all tell that this function could conceivably modify argc and argv. This is valuable. There's some problems with this rule. The rule that I like much better is actually unique pointer. This one is hopefully less contentious. The design of unique pointer, and specifically the fact that it does not have implicit conversion from T star, makes use of unique pointer to demonstrate ownership transfer a beautiful thing, even and perhaps especially in a code base with tens of millions of lines of legacy code that predated unique pointer. All right? So, for example, at no point can you be transferring ownership of a pointer across an API boundary without leaving a trace that you did so. Okay? If I have legacy code that returned a newly allocated pointer as a raw pointer, it's clear to the reader. Right? I used unique pointer, hey, now I own it. Great, that's nice. From old style returning, or from a new style method returning and storing it in blah, blah, blah. When I'm returning a unique pointer and storing it in a raw pointer, there's an explicit call to release. Right? We do expect that everyone understands the API for unique pointer, even if they're not using it or their old code is inconsistent about it. And similarly, it's clear when you're using it in new APIs. Same sort of thing applies going in the other direction, yielding ownership into a function. In all cases, at the call site, it is clear. Right? It is not necessary for every code reviewer to know the ownership transfer behavior of absolutely every function. It's clear at the call site. Right? We have left a trace. It's self-documenting. This is very, very valuable. Some other rules that help leave a trace for the reader. We really are big on override and final. The old rule used to be, in a derived class, if you're overriding a method, leave the virtual on. Right? It doesn't tell the compiler anything, but it does suggest to the reader, oh, hey, and remember, this one's virtual, you might want to go look in the parent class. Trouble is, there's lots of ways that you can screw that up. You drop a const, you have a typo, bad kerning, whatever. And if your function isn't actually overriding, right, this is very surprising, right? It's hard to debug. Override and final, solve this. One of my favorite things, although they put the keywords in the wrong spot. Interface classes, name them as interfaces. Function overloading. Our rule of thumb is don't overload if it matters which one you caught. Right? If it doesn't matter which version of the overload you caught, then it's an overload. If it matters and the behavior depends on which type was passed in, name it a different thing. right? That's a really good rule of thumb for when you should overload something, right? So, sure. And no exceptions, because error handling being explicit leaves a trace for the reader. There's other reasons for no exceptions. There are many features of C++ that are more surprising or dangerous at runtime or in subtle cases than you might think. Moving into even more explicit cases is this concept of let's just avoid the stuff that's dangerous. Right? And in some cases, you could ask the style arbiters, hey, I'm trying to do this. I know that this is the rule. Is this OK? And we might say yes, but it's going to require a pretty strong argument and probably some comments to make sure that you don't allow someone to accidentally copy and paste the wrong thing, blah, blah, blah. Static and global variables of complex type, things that have destructors that do work. In a multi-threaded system, they may have been destructed while some other thread is still running and accessing them, and then badness happens. Right? We disapprove for that reason. This is hard for a lot of people to really internalize and subtle. Using override and final, again, this avoids the surprise of why did this not work? I don't understand. I'm having blah. And exceptions can just plain be dangerous in a code base that's not exception safe. Avoid things that are hard to maintain. Right? This is kind of the meat and potatoes, like don't do silly things. Most code should avoid the tricky stuff, right? You shouldn't have to go to complex solutions. One of the guys that I work with has a great, mildly off-color anecdote, which is every code base at birth, right, commit number 1, is granted, abstractly, 1 sack of cow manure. Okay? If you are wise, no, let me rephrase. If you are foolish, you take said cow manure and just smear it all over the walls. Just paint the town with it. There'd be a template here and some macros, and whee! No one can read our code. Not a great plan. If you are wise, you use said sack of cow manure and fertilize the growth of the important stuff. Right? You only have so many degrees of freedom in a code base. Right? You need to lock that down. Right? Use the complicated stuff where it counts, where you have control over it, where the actual experts are working. Otherwise, write simple code. Right? Things that fall in this category are the obvious ones that everyone complains about: macros, template metaprogramming. In our case, we are very leery of non-public inheritance because, let's face it, most non-experts don't have a great grasp of that. And multiple implementation inheritance is hard to maintain. It's similarly hard to reason. Saved it. We have a really big code base, really big code base. So a surprising number of rules, this is getting down into very specifics now, surprising number of rules really boil down to please don't pollute the global namespace. Right? Put your own stuff in a namespace. Don't using things into the global namespace from a header. I don't care what you do in a .cc file. It is extremely unlikely that whatever damage you do to your private translation unit is going to have any impact on me. Not my problem. Right? But when you make mistakes in headers, especially if those become popular headers, then everyone that includes that header and everyone that includes anyone else that includes that header transitively forever is subject to that mistake. This has been costly. We had one instance of a foolish using that held up a compiler release because changes to the two compiler releases, because changes to lookup required, oh, hey, look, we have to add an extra include here, and now they conflict, and someone had a bad using in one of those, and we had to do more than 10,000 files worth of cleanup, something on that order. If you want to know how to do more than 10,000 files worth of cleanup, there's a talk about that at the end of the day. Go to Hiram's talk in this room. Don't pollute the global namespace, right? Even if you're a small company, the one thing that I would recommend is follow this rule to the letter, right? don't muck with the global namespace, because whatever you think you understand about your environment and context is at some point going to change. Someone's going to buy your code base, or you're going to buy someone else, and there's going to be a conflict in some global symbol, and it's going to go poorly. Don't do it, right? Namespace your stuff. Yo. Generally, we prefer using foo::bar over using namespace foo. Some of this is for explicitness, right? Back in the days before we had an indexer, right? If you had a list of all of the symbols you were importing and from what namespace that was from, it was very easy to just use find in buffer to figure out, hey, where did this symbol come from, right? Now we have an indexer, so that argument is a little sketchier. However, there are still changes to name lookup rules that stem from using namespace. And it all gets a little more subtle than I'm really comfortable trying to get everyone to understand. So I suspect that it's not worth the cost for us to change that rule. And then finally, concede to optimization and practicalities when necessary, right? We can have an ivory tower view of this is how everything should work, but from time to time we do have to actually do a build and have a performant binary. So we have some rules about optimization and practicalities. We do allow forward declarations. This is for cases where you're optimizing your build time. I use this in scare quotes because I'm, in general, not entirely convinced that this matters in most cases, at least in our build environment. I also suspect our rules on forward declarations are definitely going to change before too long, and I will try to keep the public style guide up to date. The big one that we've learned lately is forward declaring anything with a template in it is a really bad idea. This led to maintenance problems like you would not believe. Forward declaration may be okay in some cases. My suspicion is the rule is actually going to change to library owners are encouraged to provide a header that specifically forward declares the things that they think are worth it. And you probably shouldn't forward declare yourself. And nobody should ever forward declare a templated type. We'll see. We're still working out kind of the details from what we've learned. Inline functions, yes, sometimes inlining things is nice for performance. I strongly suspect that most of the guidance in the guide right now is out of date with respect to inlining. I keep meaning to sit down with our optimization people and try to work out what the rules really ought to be these days. So I suspect that'll change at some point. And then prefer pre-increment. These are just for, yeah, sure. Go ahead and do that if you think it matters. It'll make your build faster, and we don't mind. Okay. Those are the things that we're aiming to serve, and some of the rules and how they apply to those things. There are two rules that I think are contentious. There are two rules that I think are the ones that people complain about with respect to the Google Style Guide. These are them. No non-const references as function arguments, and no use of exceptions. Okay? So I'll kind of touch. Non-const references. There's a consistency argument. Right? We have 100 million lines of code that is almost perfect at the no non-const reference rule. Further, the one function that is commonly used that violates this rule has given us no end of grief. It's troublesome. We don't have it has not left a good taste in our mouth. As I pointed out earlier, leave a trace and explicitness kind of serves this purpose. And there are more often reference lifetime issues than there are pointer lifetime issues, because there shouldn't be. But in practice, people look at pointer and think, oh, lifetime problem. People look at reference and think, nothing, right? And this leads to trouble. So that's kind of the set of things that I think apply here. And one of the things that I really like, really like about pointing out why we have rules is this is more or less the bar that we would have to meet if we wanted to change this rule, right? If you are explicit about why you have set down the rules that you have set down, right, then both there is understanding about why the rule, when the rule applies, these sorts of things. And furthermore, what it would take to change the rule, right? When your mom says, no cereal for dinner, that's just a rule. When your mom says, no cereal for dinner, sugar makes you hyper and you never get to sleep, right? There's some understanding there. So you're like, oh, okay. So if I find a sugar-free cereal, then maybe we could talk, right? This is how arguing works, right? Then there's exceptions. We value the standard, but we don't idolize it. Like, not everything is necessarily applicable for our context. Consistency, yes, this rule stems from the days when there were compiler bugs. We avoided exceptions because our code was less stable, right? This is no longer the case. However, 100 million lines of code. That's not trivial to deal with, okay? Leave a trace. Exceptions absolutely don't, right? When something can go wrong, it is nice in code review for the code reviewer to look at a thing that could go wrong and see how you are handling it, or see that you are explicitly not handling it, right? In code review, in exceptions, you could argue that hopefully it doesn't matter. I'm not quite comfortable with that argument. Especially in a code base that has not been exception safe, this is a dangerous and surprising construct. Stuff is going to fall apart. It's hard to maintain. Consider, I cringe, a code base where you need to change or add additional exception types for error cases you hadn't considered before. We have gotten really good at making changes to how our APIs work. We have gotten ourselves a very malleable and very changeable, very workable, very sustainable code base. That terrifies me. Like the idea of trying to make a change like that, I don't even know where you start. And concede to optimization, because on average, code locality matters. And exceptions do everything they can to make that not the case. I would love if anyone has super good profiles in a code base that uses exceptions and can show that there is no performance penalty. I would love to talk to you. Because I really would love to have more data on this question. Anecdotally, I do not believe such a thing exists, which is sad. So, in recap, I'm leaving lots of time for you guys to, I would love to talk. Have a style guide, right? Tailor it to your situation. What things are you trying to optimize for? Right? We are very much trying to optimize for the reader, for the non-expert reader in many cases. What I fear so much is an SRE in the middle of the night who spends all of their time writing in Python being paged to deal with a production issue because some C++ lunkhead wrote a clever thing. Right? If the SREs can't follow through it without being experts, I don't want it in my code base. It's hard to argue with that, I think. Use your style guide to encourage good and discourage bad. Don't just make up rules. Think about why. And periodically reevaluate. Right? We are totally nixing the streams thing. We are reevaluating. C++11 was not instant for us to adopt, but actually fairly quick, I think. We're continually kind of reevaluating the landscape, reevaluating the options. The compelling thing that started the ball rolling there was having benchmarks that showed doing the build in C++11 mode actually got us performance improvement because there was performance improvement to be had through ambient use of moves in standard containers and the like. Right? Reevaluate. Because fundamentally, you need to be an engineer. Right? If you are in charge of your style guide, be an engineer about it. Don't be a zealot about it. Right? You should have reasons and be able to defend those reasons for all of the things that you're doing. If you're just saying, this is the way it is because I'm right, that is not engineering. That is zealotry. Right? And I don't want to work in your code base. And with that, lots and lots of time for questions. And there's microphones, which is probably better if we can manage. So I'm going to start with mics so I don't have to repeat the question.
Hey, question on one piece of background you didn't really cover in terms of what the code base is that you're maintaining. What percentage of it covers server-side code versus client-side code? And what percentage of it is on what platforms? Can you give kind of a lay of the land there?
I'd say it's primarily the back-end code. There's bits and pieces of it that are built in other environments, but historically it's been the back-end. So,
And does that mean primarily Linux as well?
yeah. Yep, you're good.
Oh, okay. On the non-const references thing, does that mean that say using swap would be bad?
No, because everyone knows what swap is.
Okay.
Right? I mean, I'm not going to be a crazy person. There are things in the standard library that you have to know the standard library. I just don't believe it is possible. Like, Hiram and I know probably more about all of the interface code in the code base than anyone. And let me tell you, it's not everything, right? Like, it's impossible for everyone to know all of the interfaces. Leaving a trace means that you don't have to. For the standard, yeah, you should know the standard. And if you don't know the standard, you see, oh, it says standard swap, I'll go to CPP reference. Perfectly reasonable. Yeah.
I actually have two questions, if that's okay.
Sure.
Number one, on the const reference thing, doesn't that sometimes reduce the readability of the function itself because you may have double pointer dereferencing, and that I never found that particularly readable.
Doesn't it decrease the readability in some cases? Yes, and I think we could have done a better job with this rule, and I suspect that there are like compiler-based annotations and things that we could do that would do an even better job for optimize, like, yes, this is clear and unambiguous. Whether it's worth doing that, given the amount of legacy that we have, I don't know yet. Like, I'm certainly open to some of those investigations, and we're doing some of those investigations. But yeah, it's contentious because there certainly are arguments on both sides.
And then the other question was on exceptions. Obviously, you're using STL type containers that throw exceptions in some cases. Do you have a policy for Do you have a policy for where you catch those exceptions? Do they have to be caught in the function that makes the STL API call?
The question is, when we're using STL containers and functions and things that throw exceptions, do we have a policy on when you catch those? And generally, we just don't, because you can use all of the STL containers just fine without using the exception mechanisms, right? Like, you lose but we have debug mode, range checking turned on.
So you look for examples where you're calling APIs that might throw exceptions, and you don't allow those according to the style guide. Is that
no, we just don't catch them.
Okay.
Like, if you're calling a thing that give me an example.
Well, get's the obvious one. Or at. Sorry.
I don't care about throwing out of memory exceptions. I just don't care. Like, until Bruce yesterday gave me the example, like, I've now heard exactly one case where you can credibly recover from that. Right? Like, I don't care. Just die. You're out of memory. Whatever you try to do to recover is going to be limping along. You're like, oh, master. Like, just die. It's fine.
Vector bounds checking, that kind of stuff.
Vector bounds checking. In debug mode, our operator square brackets does bounds checking. And otherwise, use ASAN. Right? Address sanitizer, tools. Right? If you are not using address sanitizer and you ever have a seg fault, I laugh at how much effort you're wasting. The tooling story has gotten so much better. There are solutions to this. Yeah. When Chandler points out, when you throw an exception for us because of how we've tuned the compilers, it just crashes immediately, which logically is totally what you would expect because we're just not catching it anywhere. So same end behavior. We just don't have to issue the unrolls. Yes.
We've previously used references to mean can't be null, pointers to mean null parameters, or check for null as an optional thing. If you're only using pointers, do you have any guidelines for when something might be null, or do you guys check for null all the time on pointers, or never check?
It varies wildly from team to team and context to context.
Any guidelines on what to expect as someone using an API, if it will check for null or not?
I think in most cases, it's reasonably clear. Like, if it's not intuitive, like, do I need this thing? Is it an output parameter and I'm supposed to fill in the results in this vector? You know, like, there's the unsatisfying answer is you have to go read the docs. Right? You go read the comments on the thing and it says whether it could be null or not. In many cases, that's actually not necessary because it's kind of clear from context. Like, how am I calling this? Doesn't matter. Like, could I imagine that being optional? Yeah. It's certainly one of the contentious pieces. The nullability question is big. Here.
Okay, so before I, take out my pitchfork, let me ask: is this tool, Kive, is this available and does it work on other projects or is it Google specific?
The expectation is this will be open sourced shortly. I'm not on this team, but open sourced shortly. They want community involvement. All of this stuff. And when it happens, I cannot stress enough how useful that index turns out to be. Like, for reasons I would never have imagined. It is extremely valuable. So, yeah.
Okay, so now about the pitchfork thing. Exceptions.
Yep.
You said don't use constructs that are dangerous. But yesterday, there was a talk about exception safety, where the argument was made that not using exceptions is the more dangerous approach.
Okay.
Because you are free to ignore errors.
No, you're not.
If you're returning by.
So we have a standard error class. We call it status. It's not a terribly surprising name. And we have rigged the compiler so that when you return status from a function, the build will fail if you don't do something to that object. Ding.
You can still. Okay, let's
Like,
not go into it.
there is an ignore error method on status,
But it's explicit, yeah. So
but it's
not,
explicit for the reader. So in code review, you can be like, hey, I'm not sure it's kosher for you to be ignoring that.
Yeah, another argument though, it's another argument that I actually saw in the style guide was that we don't use exceptions because our code base is not coded to be exception safe.
Yep.
So the argument also yesterday was that actually making everything wrapped in right containers and this, even if you don't use exceptions, that's a good idea.
Oh, yeah. I
So
agree.
if you were ever to, let exceptions in, you would have a good.
I would have a
argument.
miserable couple years.
Probably yes.
No, I totally agree. Like, having good containers and REI and all of that stuff, like, absolutely. Like, I am wildly in favor. Unique pointer, do it. Go, please. Have good cleanup. We have a finally type. We have all. Absolutely. No disagreement.
Okay, so just to finish it up, you also said that one of the arguments was we're going to be here for more than 10 years on this code base, right? And so do you accept that? Expect that for the next 10 years we won't see exceptions in Google Code?
On average, I would expect that's the case, yes. For most things, I suspect we will come up with a solution and be willing to pay for it. For exceptions, I'm not convinced of the value proposition. Like, I'm not sure if I could just wave a magic wand and have a code base that this worked nicely in, I'm still not sure I'd do it because of the lack of explicitness and because of compiler performance. Even if it wasn't just the legacy argument, I'm not sure. It's complicated.
So one of the problems I've seen with explicit error handling is with the standard algorithms. So say standard transform, you would usually want to return the list of transformed elements and a single error status. So how do you do the transform and half reduce kind of thing over that?
Right. So status or output parameter tie handler suggests check for your errors first and then transform. So, like, yeah.
Okay. I tend to really enjoy the standard algorithms because they all compose well, but then you toss the intermediate steps in there and it gets messy.
I would argue that we underutilize standard algorithms.
Okay.
And that's partly because legacy reasons, partly because many of our most excellent, most respected coders came up before standard algorithms was really usable and all of that. And so there's a lot of very good examples of not.
Okay.
I don't know how the balance of that will evolve over the next 10 years, but yeah, we have work to do. So this side.
You have any policies regarding ADL usage in your APIs?
There are very, very few APIs where we explicitly rely on ADL usage. I can think of only one, and much as I dislike it, it was an improvement over the horrible hack that preceded it. There was a serialization, like I would like to deserialize this information off of disk, and someone at some point in the past decided that it would be okay to let people template specialize that for their own types. And this is not the way that you extend an interface like that. So the ADL lookup solution in there, I'm less leery of.
But mostly,
But otherwise, no.
Yeah.
Otherwise, beyond that, I can think of no examples. What is ADL? Hashing soon. ADL is argument-dependent lookup. So it's the
Namespaces of arguments get included in the lookup.
yeah, namespaces of arguments get included in the lookup of the function, which is kind of backwards of what you would have expected, but it's
Only for unqualified names. But,
sure.
yeah.
Yeah. So in the middle.
Yeah. So I'm sort of curious. You mentioned that you had over 4,000 developers, engineers on your team,
No. On my team. Oh, no.
or within the organization. What was the number?
4,000-ish C++ engineers.
Yeah. Okay. So once you have a style guide that you approve, in your organization, you say this is our style guide. How do you effectively ensure the consistent application of that guide across the organization? It seems like it'd be a real big challenge.
It is. So we have things like readability. So for every change that's going to be made to the code base, like I'm making a change in C++, I need a code reviewer, possibly more than one. There are two pieces of approval that I will need. One, either myself or the reviewer must own the code in question, have rights to check into that particular directory in our code tree. And two, someone must have readability in C++, which means you've been blessed. Like, we trust you not to make a mess. We trust you understand the style guide. We trust you generally understand how things work around here, those sorts of things. Either the author can have that, or the reviewer can have that, or they can summon a secondary reviewer to review style and consistency things. So that's one. As a very human process, it's prone to human errors and judgment and things, and it's a little wishy-washy. But it works fairly well. There's also a paper out for review now, going to ICSI next year. We have some static analysis tools that have been hooked up at code review time. And this is things like ClangTidy and ClangTidy plugins specifically internal to us about our own types. And that helps identify, hey, the things that you're doing here, this is not how the style guide would suggest that you do it. Or this is inherently dangerous in some cases. And those all get surfaced at code review time, which is kind of the perfect time, actually, because that's when you are working on it and when you are amenable to change. Once it's already checked in, it's a little late. So these things make a big difference. Also, broadly, this very issue is what my job is. The title that I have worked for myself is C++ Codebase Cultivator, and that's, like I said, the Codebase is my product. So I write about what you ought to do, and I give training and all of these things to try to increase the number of people that know to do the right thing. And then I snarkily tell people, And if someone's giving you grief in a code review about something that you think you're right about, summon Titus, and I will set him straight. So that doesn't scale terribly well, but it's fun. So.
Do you modulate these rules at all for APIs that are public facing, or do you? I mean,
What do you mean by public facing?
like Google protobufs that the public uses?
So like Google protobufs that the public uses. When stuff is open sourced, it's harder. Like there's just no two ways about it. One of the side effects of we've gotten really good at, because we know everything about our code base, we can change everything about our code base, or most things. That goes out the window when you open source it, because now I don't know how your code is using it, and I don't know if I can make that change.
Badly, probably.
No judgment. And so like by nature, once you open source it, it kind of slows down any interface change. I'm hopeful that in the next few years we can revolutionize that by just, if we make an interface change to something that's being released, just ship a tool that'll change your code to use the new interface. This is not out of the realm of possibility at this point. But yes, public-facing stuff often has slightly different rules. Chromium has a descendant style guide from us with tweaks and changes for their own purposes. Yeah, like, the rules as we hold them are for the average case, but we'll be practical about it all. So, yeah.
My question is, roughly what percentage of problems does adhering to the style guide solve for you? And I'll expand on that. So even in a perfect world where all programs follow this perfectly, don't you run into higher level problems like, well, what is this modeling that you're using all about, and how do you make sure that people take a consistent approach in how to solve a problem?
Yes. This is part of why, like, running the style guide and all of that process is a 20% activity for 3 people, as opposed to a funded effort to build tools that prevent all problems. If you want tools that prevent problems, you go to the sanitizers. Where's Kostya? Kostya's not here. Go do whatever Kostya gives you. Like address sanitizer, thread sanitizer. Like your life will be so much better. You'll stop having problems.
Sure, but so how
style guide is for the things that I said. It's for consistency. It's for the ability for us to make changes to the code base and keep up with things in the next 10 years. It does prevent some bugs in some things. Generally, the overall rule of have tests and don't be dumb and don't check in code that breaks solves more of the bugs than the style guide is gonna.
So how do you then ensure that people take a more or less consistent approach in how to solve a particular problem?
What specific?
Just how they what goes into a class? How do you break them down?
You overestimate our consistency. I regularly describe Google engineering as the world's highest functioning anarchy. Yeah, like consistency is ideal, and we have a surprising amount of it, considering no one actually has the authority to smack any heads around and be like, why did you do that?
Right.
I will yell at people and be like, why did you do that? But I don't have any teeth behind it, so yeah,
right.
Whatever.
Okay.
So let's say you were starting today. Beautiful C++ 14 out there, Clang 3.5, and an empty code base, and you were tasked to redo your style guide. What would be different about it? What would be the rules that you would change or add or remove? Or what would be different?
Right. I would absolutely insist on smart pointers. I would do everything I can to ensure that the code was exception safe, but probably still wouldn't turn on exceptions. Please RAI, all that good stuff. I think I would invest some time to come up with a better solution for the non-const reference argument, because I think there is a better technical solution. I just don't know if our legacy makes it worth it. Was that?
Tuples, is that the solution? Turn everything to a
Tuple is probably not the solution. No. I think those are kind of the high bits. I might specifically just say use Clang format all the time, because there's an awful lot of verbiage devoted to where do you put the spaces. Like if I could reclaim all of the mental power of all of my engineers on like where do I put the spaces and just like please no go Clang format and then use tools. Like I would make that trade-off in a heartbeat, right? Like no question. So,
Thank you.
Yep.
Okay, so you said that you discourage or forbid.
Mike.
So you said that you discourage global and static variables, right?
Yep.
Because
Well,
they
of
cause-
complex type.
Because they cause trouble when application exits due to static destruction, right? So CppCon.
Use the mic.
Huh?
Use the mic. They can't hear you.
Yeah. So because they cause trouble when application exits due to static destruction, which is invoked automatically according to C++ runtime.
Right.
But so 3 comments. So number one, does this also apply to? I mean, do you also discourage function scope statics?
Function scope statics whose destructors run, yes.
Yeah, of course, right. But static destruction is a solvable problem. You can just call std quick exit or __ exit, which does not do static destruction.
You're
So
not
this
telling
problem
me
is
anything
solved.
new, and you underestimate the complexity and cleverness of the people that have already taken advantage of all of the degrees of freedom here. We have strongly considered just doing an experiment to turn off all of the static destructors no matter what. We'll see how that plays out. I don't know. When it turns out we don't actually pay that much cost for this rule, and okay.
So
I think it's not that bad. One of the other arbiters here disagrees. So
the actual problem, and the actual problem is on static init, when you have dependencies between static objects across different compilation units, and this problem basically cannot be solved because the order is hard. The order of static construction is hard to achieve unless you enforce linking order, which is difficult.
Also true. Yes.
Okay, thanks.
Yep. Sure. And I think we have. Are we done? 2 minutes. 2 minutes. So.
Okay. What about tab versus spaces? What's Google's take on that? If it is spaces, how many spaces?
Wait, repeat the question?
I mean, tab versus spaces.
Oh,
what's
I
your
don't care.
guideline?
Like, there's a rule about it. I forgot the rule. I just use Clang format. I don't care. Totally uninteresting. Go.
So you obviously have various platforms to support on this code base, right? You
A little
build
bit,
with different compilers. What?
The majority, no. There are some pieces of the code base that build in environments that we consider exotic. Almost all of the code base builds just for our production environment, which is glorious.
So what's your take on C++11? Do you support it, or do you have compilers that don't support it?
We support C++11 in almost all of the code. We have supported C++11. I strongly suspect that there is no code base anywhere near our size that supports as much C++11 as we do. Yes, we use the majority of it. And the pieces that are currently still on the we're not sure about list, we're working out exactly how to provide guidance on that. But like I said, this is kind of a semi-volunteer activity, so the rules evolve slowly. Yes, C++11 for certain. C++14, as soon as GCC support is there, I'm almost certain we'll just turn it on.
Yes, I was wondering, how did you get buy-in for the style guide, like when it was initially adopted? And the second question is, what did you do with all the legacy code that was pre-style guide?
So this actually wildly predates me. So the code base is kind of old. The style guide formed, as I understand it, by someone writing up a description of what the really good engineers did. It wasn't even them. And then once that was codified, the organization was still small enough that everyone was just like, oh yeah, that's what Jeff and Sanjay do, so I guess we better do that. So at some level, look to your leadership.
And legacy code?
And legacy code. For a long time, we required that any change to the style guide was accompanied by, you have to also make sure the whole code base does this, which was kind of comical because we didn't know how to do that. Now we kind of know how to do that, but we also know the cost of it, so we're not as consistent as we'd like to be, but we certainly consider all that whenever we make changes. So anyway, we're out of time. Thank you all very much.